Hey there students, today we'll be continuing our work on trigonometry by looking at angles of elevation and depression. So by the end of the session here, what I hope that you'll be able to do is be able to explain what angles of elevation and depression actually are, but also to combine that knowledge with what you already know about trigonometry to help you to solve some practical problems. Okay, so that brings us on to angles of elevation and depression. What are they? So as the names imply, angles of elevation are if you're looking upwards, so if you're looking up at a building or a bird or something like that. Angles of depression are when you're looking downwards, so down at something on the ground or looking down from the top of a cliff or something like that. What's really important about both of these is that they are measured from the horizontal. So even if the horizontal is not actually, given in the question or the diagram or whatever, as soon as you see angle of elevation or depression, you have to infer from that that they've measured that from the horizontal, both for angles of elevation and depression as well. So using my very realistic diagram here, we've got a person, a stick figure. They're looking up at a bird and down at a very mediocre illustration of a rat or similar. So the angle of elevation would be, like say if we're looking at the angle between this person looking up at the bird, the angle of elevation is measured from that, in some cases, an imaginary horizontal line. So we're taking it from there, measuring up to the angle between the person and the bird. That would give us our angle of elevation. So again, it's measured from the horizontal. Angle of depression, starting from the horizontal again, but looking at what angle we'd need to look down towards the rat or marsupial or whatever is in the illustration there. But it's really important that you measure it from the horizontal. Okay, so what does that look like when we apply it to some practical problems? And this kind of is where we combine this with the knowledge that you already have of trigonometry, in this case the tangent ratio, to solve some problems. Okay, so in this question we've got the Eiffel Tower on the right hand side. We've got point A down the bottom, so that's probably like a person or something like that, or another marsupial. We've got the distance between that point and the bottom of the tower, which is 54 meters. We've also got the height of the tower, which is 324 meters, and we've got some unknown angle between that person or whatever and the point that's at the top of the tower. So this actual question reads, what is the angle of elevation from point A, so from point A up to point B? Now, because it says angle of elevation in the question, we know that we're measuring that vertical, well not vertical, we're measuring up from the horizontal. So if I redraw that triangle on the left-hand side here, hopefully you can see this okay. I'll step back and check it. It's a mediocre triangle, so I'm just gonna have to work with it for now. Okay, I'm gonna label what I know from the diagram. I've got points A and B. I know that my length along the bottom is 54 meters. I know that my vertical length or height is 324 meters. And I don't know what the angle of elevation is. That's what I need to find to answer the question. Okay, so being a trigonometry question, I'm going to label the sides of the right angle triangle. So I've got hypotenuse, which is the longest side opposite the right angle. That's always the same. The two sides that do change depending on where either the given angle or the angle that you're looking for is, that'll change the naming conventions for the other two sides. So this side over 324 is the opposite because it's opposite the angle. And our side along the bottom here is the adjacent because it's next to the angle. Okay, we've been using the tangent ratio so far, so I'm going to write that down. So tangent of the angle is equal to length of the opposite divided by length of the adjacent. Okay, so that's my first step, is to write that down. Second step is to fill in the information that I know from the diagram. So it's still tangent of the angle, because I don't know what the angle is yet. I know the length of the opposite, which is 324 meters. I know the length of the adjacent, which is 54 meters. Okay, now because we're finding the angle this time, we need to use the inverse function of tan, of the tangent ratio. And rearranging that a little will give me inverse tan of 324 over 54. That's a little bit wonky, but that's okay. Okay, and now entering that into my calculator. So a little reminder for this one, you'd need to hit Shift 10. and then it'll often open a bracket for you, but if it doesn't, do that yourself. 324 divided by 54, which should give you 80.5 degrees, and I'll round that to, I'll say that I've rounded it to 1 decimal place. Okay, now being a worded question, if I had space underneath, I provide a worded answer, but for the sake of this video, I'm going to leave it at that. So I figured out the angle of elevation between point A and point B. I'll check to see if it's realistic. Distance of 54 meters, 324 is quite a few times greater than that. You imagine you'd be looking pretty close to straight upwards, so 80 degrees being kind of close to 90 makes sense to me. Okay, the next question that we're going to do is a little bit more tricky, but that's fine. Okay, so first of all, we'll start by reading the question out. So we've got a person called Will who is stood on top of a cliff looking down at his beach house. You'll find that in these trigonometry and Pythagoras questions, there's often a cliff or a ladder or a kite or something like that. It's really the trigonometry best of everyday topics. But in this case, we're on a cliff looking down at a beach house. The angle of depression between the top of the cliff and the beach house is 30 degrees. The cliff is 20 meters high, and the actual question is, what is the horizontal distance between Will and his beach house? So let's look at the key bits of information that's been given. We know what the angle of depression is between the cliff and the beach house, that's 30 degrees. We've got the height of the cliff, which is 20 meters, and we want to find out the horizontal distance between Will and the beach house. That's kind of hard to get your head around without drawing a diagram, so I'm going to start by drawing a pretty simple diagram to kick things off. I'm going to say that this is my cliff. I'm just going to make it vertical because it says that in the question somewhere. I'm going to draw Will just for fun. There he is, remarkably similar to the stick figure from the previous question. We have a beach house further along the waterfront, so I'll draw that as well. Okay, what else have I been given in the question? Okay, so we've got the angle of depression between the top of the cliff and the beach house. But remember that the angle of depression is taken from the horizontal. It's from the horizontal going downwards. So the temptation is to put that angle here, but because we're measuring it from the horizontal, that angle actually belongs there because it's from the horizontal. So that angle of depression is 30 degrees. I'll fill that in as well. The cliff is 20 meters high, so I'll fill that in as well. Cliff's 20 meters high. And the actual question is, what is the horizontal distance between Will and his beach house? So I'll just call that X. Okay, so now we've got a bit more information and we're a lot more closer to solving this problem. What I'm going to do now is draw this right angle triangle up here. And this is what I'm going to label to help me solve the problem that's given in the question. So I've got X along the bottom, that's this distance here. I've got a height of 20 meters. No, what's really, really important in here is that we have the correct angle inside the triangle just here, otherwise it's not going to work properly. So if our angle of depression is 30 degrees between here and here, what we need to do is figure out what this angle is here, because that's going to give us that interior angle of the triangle that we're going to use to help us with our trigonometry related problem. So if this is a right angle, if this angle plus this angle here would add up to 90 degrees, the angle that's inside the triangle has to be the difference between the two, which in this case would be 60 degrees. So I know that my triangle that I'm going to use here has an internal angle just at the top here of 60 degrees. Now this all of a sudden looks like a pretty straightforward trigonometry problem. I'll label the sides of the triangle. I've got my adjacent, I've got the opposite, and even though we're not going to use it, I'll label the hypotenuse anyway. Okay, so I'm going to use the tangent ratio for this one. So tan of the angle is equal to opposite over adjacent. Now I'll fill in the information that I know from the question. So tangent of the angle, which is 60 degrees, is equal to the length of the opposite, which is x. We don't know that yet, but we are going to solve for it in a second. Divided by the length of the adjacent, which is 20 meters. Okay, Next job is to do a bit of rearranging. So if x is being divided by 20, to get it on its own, I'll need to multiply both sides by 20. So that's going to leave us with x is equal to tan 60 multiplied by 20. And if I grab my calculator, I'll do the same thing. This could have been a here's one I prepared earlier, which is perhaps something I will do next time. Okay, tan 60 multiplied by 20. That's given me an answer of 34.6 meters. And I've rounded that to 1 decimal place. So I'm going to say that I've rounded it to 1 decimal place. Okay, now we'll check to see if it's reasonable. So we've got an angle of more than 45 degrees, but not by heaps more. So we'd expect this number here to be bigger than 20, but not by a huge amount. So 34.6 sounds about right. Okay, so there are 2 examples of angles of elevation and depression. Remember that you always measure them from the horizontal in either direction. And bear in mind that the angle that's given in the question might be different to the one that you use in your trigonometry ratio. Thanks for watching.